All right, so we are going to be learning about the last item of our Unit 2, absolute values, and we're going to be solving absolute value inequalities. So let me tell you this first key tip for solving absolute value inequalities is you're going to follow the same steps as equations, and you're going to flip the inequality signs when you change the integer. I'm going to put a box around this, a bubble around this. Great. I'm going to put a little bubble around here so you know that it's not anything different. It is the same as solving the equations, except the only additional thing is flipping the inequality sign when you change the integer. So here's an example. We're just going to do a couple of examples and then you can try. So here's example 1. It says to solve the absolute value of x minus 5 is less than 2. So that first step is to isolate your absolute value bars. Well, our absolute value bars are by itself on this side of the inequality, so it's already done. So step 1 is done. Check that off. The second step is to write two equivalent equations. So we have x minus 5 is less than 2. And our second equation is going to be x minus 5 and the negative 2, except we're going to flip the inequality so it's greater than negative 2. And then we'll solve. So on this side, we're going to solve by adding 5. So we have x is less than 7. And on this side, we're going to solve the same way. Add 5 and x is greater than 3. So what this looks like on our line is x is greater than 3. So I'm going to start with the smallest number, go to my larger number. Here's 3, here's 7. They're open circles because they're greater than and less than, and it's less than 7, greater than 3. We're coloring toward each other. Okay. All right, let's do the next one. So these are both answers. Here's example 2. We're going to solve the absolute value of 3x minus 4 is greater than or equal to 5. So if I look, my absolute value bars are isolated on this side. So my next step is to write two equivalent equations. So, well, in this case, inequality. So I have 3x minus 4 is greater than or equal to 5. And 3x minus 4 is less than or equal to negative 5. So we'll solve this side first by adding 4. 3x is greater than or equal to 9, and then divide by 3. X is greater than or equal to 3. So that's one answer. Same thing over here, add 4, follow the same steps. 3x is less than or equal to negative 1. Divide by 3, and x is less than or equal to negative 1/3 would be my answer there. Okay, so what that looks like in our number line here when I graph it, I have a negative 1/3. Put your smaller number first. Oop, I put 1/2. That's 1/3. And a 3 over here. They are also equal to, so I'm going to shade those in. This says x is greater than or equal to 3. So I'm going to color it this way. X is less than or equal to negative 1/3. So I'm going to shade it this way. All right, you have 2 try questions to do. All right, so your first try is going to look a lot like this second one. So here's the first one. It says 2x plus 1. The absolute value 2x plus 1 is less than 3. And your second try has a number attached, and it is 2x plus 4 is greater than 8. So you try those and we'll complete them together in class.